Yeah, so Mr. Richard is with us now. So say I would kindly like to call upon you to lead the session for the evening. Thank you.
Okay, good evening, everyone.
Good evening, sir.
Good evening, Mr. AKs.
Okay, so today we'll be looking at functions, conditionals, and let's just stick to that for today. And if we have time, we will look at loops. But for starters, let's just look at conditionals. That's what we are coming to look at today. So I'm going to create a notebook. Uh, sorry. Okay. Um, so you look at conditionals and functions today. So let me create a notebook to work in. You can open an Anaconda notebook and then work in. Sorry, a Jupyter notebook and work in. It's all the same thing. But I think for the sake of my network, I'll be using the Anaconda Navigator instead. Um, my network is really bad today, and we have 23 minutes already gone. Where is it? Okay, so welcome back once again. So today we are going to be looking at conditionals and then functions. Okay, what we mean by conditionals is that um, we want to execute a statement or a block of code based on a certain condition. For example, let's go back to like our normal daily life. If I say that today is Saturday, then it's a weekend.
Hey,
If I say today
hey,
is
please, can you
Monday,
see your screen?
is that?
Yeah, it's in now. It's in now. I think it's the network. Okay.
Yeah, my network is bad today. Okay, so so as I was saying, we evaluate certain conditions and then we give uh, a response to that. Basically, that's what we mean by conditional statements. So um, conditionals. So let's say um, we want to check if someone is eligible to vote. I'm going to give an example and then I'll use that in code. If you are less than 18 years, it means you can't vote. If you are more than 18 years, it means you're eligible to vote, right? So on December 7th, you walk up there. So far as you are standing in a queue, it's general that you are eligible to vote. That's why you are there. So we evaluate a condition as a Boolean statement. Uh, Boolean statement. What we mean by Boolean is that anything that has a value of true or false. It's binary. It can either be true or false. Like you are asked, are you 18 years? You can't say maybe. It's either you are 18 years or you are not. So that's one classic example of conditional statement. And following Python syntax, we use blocks indentations to work with conditional statement. And as it is known with many popular programming languages, we use the if condition, just like how it is in English. If today is Monday, it is a weekday. If today is Saturday, it is a weekend. So I can say that if, so first I'll create a variable here called, sorry, age is equal to 18. So I've created a variable called age is equal to 18. And I'll say if age is equal to, sorry, is greater or equal to 18, then so it's as I press enter, it jumps into the next block. Then print so now we run this code and then we get the value of you are eligible to vote here. Now if I was to change this to 16 and I run this, we don't get any output simply because we are not 18 years or we are not greater than 18 years. So we don't get any output. So basically, a conditional statement checks for either true or false. There's no in between, there's no maybe. Not like our girls, you propose to them and then they say maybe, like they call it talking stage. You don't have talking stage in Python. It's either true or false, it's either yes or no. So that's what Boolean stands for, a true or false statement. So if you are evaluating any condition, we use some operators, comparison operators like this. So if you are checking equal to, earlier on, I told you that this is assignment operator. We have double equal to sign. This is equality, okay? Or this is the actual equal sign. And this is assignment. The equal to, the single equal to is assignment, and then the double equal to is equality. That's the actual equal to sign. In other programming languages, you're going to see three equal to signs, but let's forget about that for now. Okay, so we have the assignment and then equality. So if you want to check if the age is exactly 18 years, you use double equal to. When you run this, we get nothing because age is 16. If you do 19, we still get nothing because 19 is not equal to 18. But if you do 18 per, then we get you're eligible to vote. If we do greater, so just like mathematics, greater or equal to, we get it. If we put 19, we get it. So the condition, the operators here, we have the equal to sign. This means A is equal to B. We have the not equal to sign. That's an exclamation mark before the equal to sign. Okay. So A not equal to B. So take notes. The exclamation is used to negate a statement or a variable, a value. We say A is less than B. This is primary school mathematics. A is greater than B. A is less or equal to. Please, the less or greater comes before the equal sign. So A is less than or equal to B, and then A is greater or equal to B. Please kindly take note of this. Okay, so since we have this, then let's go ahead and then look at something. Now, if the person is um, equal to or greater than 18, we get you eligible to vote. What if the person is not equal to 18? So we can come ahead and then say else, right? The else simply means that if this statement is not equal to true, if this statement is false, always the statement here must must be true for the underlying underlying block to be executed. So this should always be true for this line to be executed. Now, if this line is not true, then what is in this block is going to be executed. Underline and return as meeting. So we can see something like this. So now let's run our code. Since the person is 19 years, the person is eligible to vote. The person is 16 years. Now you are not eligible to vote. Try next 4 years. So this statement, since this statement is not equal to true, this was ignored. Okay, it will totally ignore everything in this block. Now we start a new statement. Okay, the else simply means that if this is not true, this should happen. So we jump to the else block and then say you are not eligible to vote now. Try again next year. So since this is false, this is what get executed. Now let's do something uh, a bit typey. I have to type a lot for this one. So let's say um day is equal to Monday. If sorry, if day is equal to Monday, sorry, print so nobody likes Mondays because it's a weekday. Now I want to check. This means we are checking for only Monday. Now let's check. If it is not Monday, I can say that you say today is not Monday, less pressure. So when oh sorry, I didn't close this. So nobody likes Monday because it's a weekday. Oh, what is this? Okay, so if today is equal to Monday, if the day is equal to Monday, see this. If the day is not Monday, say today is not Monday. It's so less pressure. So let's change the day to let's say Tuesday. And when we run it, we get today is not Monday, less pressure, right? Okay, let's see. Let's run through the days. So now what if the day is not Monday, but then we want to check for another day? We use what we call if, right? So if means, in other languages, it means else if the day is not Monday, but then the day is this day. So if day equal Tuesday, print, uh, let me just make it simple, weekday to Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So Saturday is a weekend and Sunday is also a weekend. I think I can tie close. Okay. Uh, So let me just so here we can choose any day, right? And then if we run the code, we supply Tuesday. So this means that if the day is Monday, it's a weekday. If it is uh Tuesday, it's a weekday. If it is Sunday, we say it's a weekend, right? Okay. So this is a very long code. It's bad, but this is a brief understanding of else if statement. I'll just take, let me take all the way up to this place. Say age equals 45. Now, before we do all this thing, let's look at one thing we've not talked about. It's just a quick 1 minute thing. Okay, so we can collect input from the user, right? And we use that using the input method. What this method does is that it prompts the user to enter a value. Please take note that whichever value you supply is a string, not a number. It's a string. So if you want a number, you have to manually convert it to a number. So here, I'll do something like age, right? So I'll just assign age to input and I'll say enter your age. I'll come down and say if age equal 18, sorry, I can say if age is greater than 18, and then last I can do else and say you're not eligible to vote. So this So let me run this. I know I'll get an error. So you see, there's an input here, there's a prompt here, enter your age. That's what I've specified here. And there is this search, this box here asking me to input an age. So I'll say 24. I get an error because, as I said, this input accepts only strings, right? Even though I entered a number, it accepts only strings. So what we can do is we can just clean this and then say age is equal to int age. This means we are just converting the age. Let's say output. Where is it? We are just converting the age to a number. So when we do this, I'll say 24 and I get, you can still vote, right? Because 24 is greater than 18. Space this out. If I run it again and I enter 17, we get, where's the pending output? Really? All right. So let me run it. So if I say 17, we get you are not eligible to vote of Ben. So that's the basics of conditionals. This is the first statement we check whether it's true. If that statement is not true, you come along to check this. You can use as many if statements as you want. And then this last else means if any of these statements are not true, any of the preceding statements are not true, this is the last thing to be executed. Okay. Ha, really? So that's about if statements, conditionals. So please go to Kaggle and then read more over here. Our time is almost up. There are more examples over here. So please go to Kaggle and then read more there. Now I'll quickly look at functions. So functions. So functions helps us to modularize our code. This means we can group the blocks of code together to perform a specific function or task. Okay, so basically all this we are doing, we are just inputting raw code like that. Now we want to create a code that checks for, let's say, that just simple addition. Okay, so in Python, when we are creating a function, we start with the word def. This simply means we are defining a function. So function definition. The next thing that comes is the name of the function. We are going to say add nums, which means it's just anything. So you can put like how we create variables. So just like how we are creating variables, but here we use def, okay. And then we bring this bracket and then this colon. So what happens here is that we can return a value from this. I'll say return 7. Now, if I come all the way down here and I print I print add nums plus 5, and I run this, I get what 12 because this returns 7. So it assumes that this is a variable, a value of 7. Let's just take it like that. Or a variable, right? That waits for the result of whatever is inside and then returns it. So this returns 7. So 7 plus 5 is equal to 12. Let's do something more beautiful. we can have this here, which is add numbers. So what this means is these two things, okay, is what we call uh, parameters. Parameters. So they are basically variables or placeholders that prompt you that you are taking a number or a string. We are taking a value here. So we can come down here and then say that now what I already have, since we have placeholders here, if I run it, I'll get an error. Okay. So it says missing two required positional arguments. This is the parameters, and we have to supply in values. So I'll say 7, comma 12. So let me just take this one away. So what I'm doing is I'll take a number A and then number B. So I'm taking two numbers. 7 stands for A, B, 12 stands for B. So what I'm doing is return A plus B. 7 plus 12 gives us 19. Okay. So that's one basic example of uh, parameterized functions. I can do another function says multiply numbers, and I'll say A B is equal to 2. Yeah, I wanted to, the time is already up. I wanted to finish and then take the questions if that would be ideal. Okay, Gideon.
Yes, sir. Thank you, Mr. Akins. I wanted to know if the return you can bring the numbers there and then use the characters to print them. Is it possible that way?
I don't get you.
Like for the return, you see, you have two characters, A plus B. So now I'm
Yeah,
saying that can you bring the 7 and then 12 and then you represent them? You bring the A and B in the bracket to print them. Is it possible that way?
like I will replace this like
Yes,
this.
please. Yes.
Okay,
And then the
so
seven,
what
seven
this,
and 12 will come. Okay.
okay, this, what the reason why we create functions with parameters is to allow us to dynamically pass in any value. Okay, as you can
Okay.
see over here, we have a we are adding two numbers. So this function here allows us to add literally any two numbers you know of, so that we don't have to statically. If I do uh, 7 and then 12 here, okay, and then here when I'm running the code, I do 5 and then 200 here. Even though this will still be passed onto the function, it will still return 7 plus 12, which is 19. And we don't want that. What we want is that
Okay.
whichever two numbers you place here will be taken into the function, and then the addition will be done on the two numbers we do here. So here you see A and B, where the A stands for the 5 and then B stands for the 200. So we run it and we get 205. If you put 51 here, then we can get 251. So functions allow us to do computations dynamically so that we wouldn't have to manually be adding the numbers inside. We are, let's say we are creating a calculator. You don't know what the user is going to uh, add or multiply in there, right? So the function is like a placeholder for them that accepts their input and then it processes based on the input. So add nums, you've
Okay.
defined a function that a user is supposed to input two numbers. So when the user inputs those two numbers, add the two numbers and then return the value. So I chose 51 and 200. When I run this, it gives me, it sends the 200 all the way, sorry, the 51 all the way here, because the 51 will pass through this A here. The 200 will pass through this B. This B will descend down here. This A will come down here. I don't know if you are getting the picture.
Yes, please. Yes, please.
Oh, so by that. Okay. So if I pass the 200, or let's say the 51 will be here, and then the 200 will jump into the B. 51 will jump into the A. Now A is
Okay.
51, B is 200. You run it, you get A plus B, right? 51 plus 200. So it works for any two values you replace there. Okay.
Okay. Thank you.
So these are called positional arguments. Okay. Now the next one is oh sorry. So we have default values. This means, so what this means is that we have a function that multiplies the value of A and B. So if I input 5, the 5 stands for A, the 6 stands for B. So 5 times 6 is what? 30, right? Oh, I'm missing a bracket. So we get 30. Now this B equal to here is a default value, which means that if I don't supply anything for the B, any value for the B, it will use 2. So here, if I delete the 6 and I leave only the 5, it is going to be what? 5, that is the A, times B, which is 2, because I'm not giving any value for B. So when I run this, I'm supposed to get 10. Okay, so 5 here, that's the A, times B, which is already 2. We are saying this, we are doing this because sometimes we want to leave a default value so that when the user doesn't supply anything, we have a default value for that. Um, the next thing, should I stop? So yeah, basically this is that you can also add a default value for this and you can run it. If there's a default value and you actually supply a value, the value you supply will override the default value. Okay. So this will only work if there's no value supplied. Now, if I don't supply any value here, since I've already given A a default value of 3 and B default value of 2, it's going to perform 3 times 2, right? A times B. Since I didn't supply any value here, which will give us 6. So now let's do something. So we are creating uh, a simple function that squares any number. So we are going to see num as the variable, and then power is equal to 2. Let's just do it like this. Or no, let me just take this. So you see that return number star star 2, since star star means exponent. So when we come down here and then we see uh, num squarer, num squarer. So let's just say my num is equal to int input enter n number to square, enter a number, just that. To say my, so what I've done here is that we've created a function that takes a number and then it squares the number. Now, when we come to this line, we prompt a user to enter a number, right? We convert the number to an integer, okay, because the input returns a string. So whichever number you enter, and then we pass that number here. Now that number will go all the way down to here, right? So that we don't have to manually put in a number here as we have been doing previously. So we run this code and it says enter a number. I'll say 4. So when I run this, oh, I have a pending input, so I have to stop this and run it again. So I say 4. Oh, so it returns 16, right? So I can say what the square of, where is the number? I num is, okay, square. So I enter 5, enter. So it says the square of 5 is 25, it's square. So this helps us to dynamically multiply any number. So let me run again. I run 3. I always forget this. I have to press enter. So you see the square of 3 is 9, right? So this helps us to um, take input or take numbers dynamically. To make this cleaner, we can even move the input here. So if that is the case, we are going to take away the parameters or the argument. But that would mean that we will not know the value we supplied. So here we run the code and then inside the function, we take the number inside the function and then we return the number squared. Okay. So 6 and then the square is 36. That means we are only using the print statement to print the result. Where we are taking the input and everything inside the function. When you come to Kaggle, go back, the Python course, we have functions as the second module here. So if you come here, you can read and then get more understanding of functions. So I would like to end here. I think I've touched functions and conditionals. I think that's okay. That's enough to get us started. So these are the basics, some few basic things you know in basic Python. We'll be looking at all these things as we go ahead, and then we'll be learning new things. But for now, we'll end here and then we'll start getting a bit serious as we go ahead. Okay, so that will be the end of today's lesson. Next Wednesday, we'll be looking at NumPy, pandas, matplotlibs. We are actually going to do something concerning machine learning. So that'll be all for today. If you have any questions, please shoot them. Yeah, Gideon.
Yeah, Mr. Hawkins, I wanted to know if Indentations are very important in Python.
Yes, they are very important in Python.
Oh, okay. Right.
Please, any questions?
If
Okay,
you have
so
any,
if
if
Derek,
you
do you
have
have a
any,
question?
no, no, no. I was about telling them if they have any questions, now is the time to ask. If the question is from the previous session or this current session, it will be advisable to ask because in the subsequent meetings we'll be moving fast, just like we are moving fast now. So they should try asking their questions. So
Okay,
I
so
think they
if
don't
there are
have
no questions, is there?
I think they don't have any questions.
Yeah, so I'll leave the meeting over to you.
Okay.
Okay, thank
So
you.
okay, you're welcome, say, and thank you for the session, say. Okay, so back to our members. First off, I would like to thank everybody for taking out time to join the session for this evening. Yes, for me, I'm learning a lot. I'm learning quite a lot. So I don't know about you, but I think you are also learning a lot. I would like to encourage us or to entreat us to always join the meeting on time so we can optimally use the 1 hour that we have for each session. Not that we'll spend 17 minutes or 20 minutes waiting for um a substantial amount of people to join before we start late and then we try ending on time. So please let's kindly join the meeting on time and then also share the links that we've sent to you, the links that you use to join the meeting. Share the links to your friends in other universities. We are doing a machine learning study jam where we are teaching Python, machine learning, and then a little bit of AI. So a lot of people would be interested in this. They said information is power. So kindly try to share this circular whenever you get it to your friends. So you also have a lot of people in the attendance list so you can interact and then sometimes even do some group studies together online or something. So those are the two things I wanted to add. Thank you all for coming again. Thank you, Sir Akins, for taking us through the session and then sharing a lot with us today. Me, I'm going to the Kaggle to do some things there. I'll do some magic. So, okay, so also, if you are wondering where you could access the recording to this session and other previous sessions, the link will be shared in the chat so you can. Yeah, it's on YouTube. Sorry, it's on YouTube. So kindly go to the GDG on campus YouTube page and then access the recordings there. With that being said, I call the session to an end and thank everybody for attending. Thank you and have a wonderful evening.
All right. Thank you too.